All right, so next up, we're going to talk about errors in hypothesis testing because statistics, unlike mathematics, we can do everything completely right and still be wrong. So there are two types of errors that can be made, and these really depend on what is the truth, which sometimes we will never actually know, and then our decisions. So if we reject the null when it's actually true, that would be an error, and this is actually what we call a type 1 error. Rejecting the null when it's false, this is a correct decision. Failing to reject a true hypothesis is also a true decision, a correct decision. And then failing to reject a false hypothesis is our type 2 error. So this is a question I love to ask about on the exam, specifically, what are these errors in context? So I have an exercise here about the boy who cried wolf. So the null hypothesis, what everyone assumed, all the villagers, right, assumed, was that there is no wolf. Provided enough evidence, i.e. a boy screaming, they may make the conclusion that they can reject that there is no wolf and actually there is a wolf. So our type 1 error is that the villagers would reject this, make this a conclusion, right? So that will be their conclusion. They go, okay, villagers... Oh, that's not how you spell villagers. I should have tried this out beforehand. Villagers decide there is a wolf. But, so they rejected the null and they decided this, but they made an error. Turns out the null was actually true. So, villagers decide that there is a wolf, but there is no wolf. A type 2 error, on the other hand, this is when you fail to reject the null. So, essentially, there's not enough evidence for them to reject this. So, the villagers decide there isn't enough evidence to think there's a wolf. So, they decide there's no wolf. Slightly different than our actual hypothesis testing, right? In hypothesis testing, we never get to conclude the null. But again, they just assume here we don't have the evidence to think there's a wolf. We're just going to sit at home and continue watching our Netflix, right? So the villagers decide there's no wolf, no reason to get up. But the reality is there is a wolf. So this is one way to remember type 1 and type 2 error, because in the boy who cried wolf example, the villagers made a type 1 error first, right? They decided there's something was going on when there wasn't anything going on. And then they made a type 2 error. They went in the other direction and said, well, now we're going to assume nothing's going on, when in fact there actually was. So there's your type 1 and type 2 errors. Another way I like to sometimes do this is think about the type T1 being T on the first hypothesis, and the T to me stands for the truth, which means our decision is the other one. So the truth is there was no wolf, the decision was that there was a wolf. So it's a different way to think of it, and I'll use that method on the next one, but you have multiple ways you can handle this on the test. So the probability of our errors, type 1 error is denoted by an alpha. So when I talked about our significance levels before in 6.4, or earlier in 6.4, I said we're going to talk about alpha again, and I'm going to tell you that it's actually our threshold for the amount of type 1 error we're willing to make. How often are we willing to go run up the hill to see if the boy is crying wolf falsely? If I'm willing to do that 5% of the time, that's my type 1 error. Type 2 error is denoted with a beta. So I'm just going to add those to our table. The probability of a type 1 is our alpha. Probability of our type 2 is a beta. All right, and then there's another thing called the power of our test. The power of our test is our test's ability to detect a false hypothesis. It's basically our ability to do what we want, which is provide evidence in support of our alternative hypothesis or reject the null, given that we should actually be doing it. It's not powerful for me to reject the null if I'm doing it incorrectly. It's only powerful for me to reject the null if I'm doing it correctly. So if you wanted to add that to our table, that would be here. Power is rejecting the null when it's actually false. We don't have any cool name for this little thing, even though it's a correct decision, because that's basically saying there is not enough evidence to show something that was wrong is wrong. All right, so anyways, we've got all that stuff going on here. So I want you guys to try out the next two exercises, especially exercise 6. So take a moment and see if you could identify the type 1 error in context. This is exactly like a test question. So hopefully you attempted this on your own. On all these questions, I will generally tell you what the null hypothesis is. So in this case, I stated that the null hypothesis is that you have enough gas to get to school, which means our alternative hypothesis is you don't have enough gas. And we're going to be looking at a type 1 error. So 2 ways to do this. We can either remember type 1 is rejecting the null when H naught is true. So we'd reject this and decide that. Or we use the truth decision thing. So type 1 means our T or our truth is here, and this is our decision. So let's look through our answer choices. One thing you want to do when you have this question on an exam is get rid of any correct decisions before you even go look for your type 1 or type 2 error. So A says, on the way to school, you stop at the local gas station and put gas in your car, and it takes 11.9 gallons of gas, and you have a 12-gallon gas tank. So you stopped and got gas, and you needed gas. This is a correct decision, so we can go ahead and get rid of it. It will distract us, I promise, if we leave it in there. B says, on your way to school, you choose not to stop for gas, so you did not stop, and you run out of gas. That is definitely an error, so we're going to leave that in. C, on the way to school, you choose not to stop for gas, and you make it in time. No error there. And then D is the other error. On the way to school, you stop to put gas in your car, but there was plenty already in the tank. So you stopped to put gas, but there was already plenty in the tank. So we need the one that says our decision was that there's not enough gas, but the truth was there was. And that's exactly what D does. We decided there wasn't enough gas, so we went and stopped, when in fact we had enough gas, so we just wasted our time. B would be our type 2 error. All right, we could even bring this into exercise where we talk about the court case example. So in the court case example, right, the null hypothesis is that we have to assume the defendant is innocent. And our alternative is then that they are guilty, right? That's what we're trying to prove. So a type 1 error is when we reject this and decide this, right? Except that was actually true. So a type 1 error is convicting, an innocent person. You can think of this as Shawshank. Right, Andy Dufresne. All right, type 2. Well, it's the opposite. This is failing to reject. So I failed to reject. I don't get to prove that they're guilty. So I end up acquitting a guilty person, or letting a guilty person go free. We got our O.J. Simpson. Right, so those are our type 2 and type 1 errors. In fact, let's go ahead and add one more I didn't ask for. Let's talk about what power is in this context. So power is our ability, remember, to reject the null, to convict guilty people. As a prosecutor, I'm not really looking for my ability to acquit innocent people, because I never think anybody I'm taking to trial is innocent, so no special name for that, but definitely a special name for my ability to convict people I think are guilty. So there is a nice relationship between our alpha, our beta, and our power. They all kind of come back to this. I like this example because type 1 and power move together. So basically, if you increase your alpha level from 5% to 10%, This means that we're going to increase our type 1 error. We're increasing the acceptable amount of type 1 error. So if we're thinking about this example above, we're accepting we're increasing the likelihood. We're saying it's 10% of innocent people behind bars is okay with us. That's terrifying, but let's just go with that example. So what's going to change then? All right. So what else will change? This doesn't have it doesn't actually ask, but what's going to happen to my type 2 error? My beta. Well, if I'm convicting more people, incorrectly or not, I'm going to acquit less incorrectly, right? Acquit less people in general. So our 2 errors are a trade-off, much like everything in statistics. If you increase one, you decrease the other. So if we're trying to decrease our error, we will decrease our type 1. We'd actually end up increasing our type 2 error. So if we go, oh crap, I really don't want to convict innocent people, so let's increase the burden, right? Then we're sitting there going, okay, well that's great, but I'm letting a lot more guilty people go. So there's always that trade-off. And then our power, well, our power is about convicting, so it moves the same way as type 1. It's also 1 minus beta. This is the only time we actually have a complement. So our power is always moving the opposite of this, because they're both about this thing going on behind the scenes, this condition that our person is essentially guilty. So if the person is guilty, there's 2 different situations that could happen. You kind of imagine our tree diagrams, right? So if we have our guilty or innocent people, then we have 2 options: convict or acquit, convict or acquit. Convicting a guilty person, this is our power. Acquitting a guilty person, this is our type 2. So you can see how those 2 things go together. And then innocent person convicting, this is our type 1. And acquitting an innocent person has no name at all, but it's a correct decision. And then our last thing here, I think last, yep. What will the impact of increasing our sample size have on these errors? Well, increasing our sample size can't impact our alpha. Our alpha is a set value, so this will stay the same. This is what we set ahead of time. So changing our n doesn't do anything for that. But otherwise, increasing our sample size, all good things happen. So our type 2 error, if we have more evidence and more information, our error is going to go down. And our power will go up. So increasing the sample size will have the same effect as increasing our alpha without increasing our type 1 error.